Alright folks, this video is about this slide number 17 in chapter 13. And when we discuss the problem on this slide, what we are trying to do is to solve the rate law of this particular reaction. So let's review what we did. Okay, so the first step is to set up this equation for this reaction. Rate equals to K times the NO2 concentration to the M and the CO concentration to the N. And remember, this is always the starting point when you try to solve the rate law by using the concentration chain, initial concentration and the initial rate. So the next step is you take the ratio between the rate 1 and the rate 2. So, these are the equations, and you can cancel the K, cancel the item with N, and in this equation, and you can solve the M equals to 2. The next step is to take the ratio between the rate 3 and the rate 2. Again, you cancel K, you cancel the item with M, okay? And then what you have is just the item with N, so you solve the N as 0. Alright, the last step is to solve the value for K. What you need to do is you put the value of M and N in the rate law. So here is what we have. You have only K left. And remember, since CO is zero order reaction, so you have you don't see the concentration of the CO in this equation because it's 1. Alright, so and like I said, when you reach this step here, you can use either one of the 4 experiments to solve K. What I did here is to use the data from experiment 1. Okay, experiment 1, and you have the rate, you have the concentration of the NO2. You can solve the K at 0.21 liter per mole per second. This is what we did. Okay, it's regular procedures. Now, remember the challenging question I asked is, once you solve the M, okay, once you solve the M, can you use the ratio? Can you take the ratio between the experiment 3 and experiment 1? Okay, experiment 1. When you take the ratio, can you solve the N? Okay, so in our lecture, some of you said no, some of you are not quite sure. So let's see what happens if we take the ratio. So this is alternative procedure to solve N. So let's put that as a 3 prime. Okay, step 3 prime. So again, we follow the same strategy. You have the K, you have the rate 3, and the concentration of the NO2 is 0.20 mole per liter to the M. Okay, and the CO concentration is 0.20 mole per liter to the N. And the bottom parts, the concentration of the NO2 from experiment 1 is 0.1 mole per liter to the M, and the CO concentration is 0.10 mole per liter to the N. Alright, now remember, in the regular step, we said that, okay, you can cancel the K, you can cancel the K, you can cancel the item with M, right? So you have only N left. Here, you cannot cancel the item with M because the concentrations of the NO2 is different in these 2 trials, in these 2 experiments, so you cannot cancel them. The only thing that you can cancel is K. So what should we do? Okay? But this is not a dead end. Remember, after the second step, we've already solved the value for M. So what you need to do is just plug the value of M into this equation. So the rate 3 from experiment 3, that is 0.0083 mole per liter, okay, per second, over 0.0021 mole per liter per second. So here's what I'm trying to see. You have 0.20 mole to the 2. We know the value of m already, so we plug that in. 0.10 mole per liter to the n. And now, as you can see, even if we cannot cancel the items with m, we can still solve n. Because again, the n is the only unknown value in this equation, right? You can calculate this part, and then this part, okay, that is about 4. And this part, that is also about 4. And, okay, and you have 0.210 mole per liter and 0.10 mole per liter to the n. Still, you will get n equals to 0, as you can see. Okay, after you got one of the reaction order, and you can either basically take either one of the 2 experiments to get the other reaction order. For instance, another way, okay, 3 double prime, is to take the ratio between the experiment 4 and experiment 3, and you can try it. I guarantee that you'll get the same answer of n. Okay, so here is how we solve this challenging question. Hopefully it can help you understand the whole reaction, the system a little bit better. Please let me know if you have any questions.